is just like 31, but now we're going to do cosine. So we're going to say cosine of x is equal to negative 0.7. Okay? Now, algebraically, if I wanted to get one solution for this, I would hit it with the cosine inverse or arc cos on both sides. And then what happens is that the cosine and the inverse cosine cancel out, and I get x equals cosine inverse of negative 0.7. Okay? And so I can enter that in my calculator and get a value for that right off, rather quickly. Right? So if I hit arc cosine 0.07, or 0.7 I mean. Oh, it's negative, yeah. Sorry. Negative 0.7. The calculator will spit out x is equal to 2.35. Let's just go another decimal so you guys can see. 2.346. Okay. Now, our boundary on this one is 2 pi to 4 pi. So now here's a challenge. We want x to live between 2 pi and 4 pi. Well, is this 2 times pi? Our answer we got from our calculator? No, because this is actually like 6.8 if we were to find the decimal approximation of 2 pi, and then you would double that. What is that, 1256, yeah? So x is nowhere even close to that. Okay? So now so let's look at the graph. What we're going to have to do, if I come in here and I'm going to change this to cosine of x, and then I want to change this to negative 0.7, and when I graph that, there's a whole bunch of them, and so I'm going to change my window from 2 pi to 4 times pi, and now I'm going to look at the graph. Okay, maybe I'll change my y, because that's a little big. I'm going to go from negative 1 to 1, and now we'll zoom in a little bit better. So we see that it only crosses 2 times. Okay, now how do we find those values? Well, if I were to guess, what is the period of cosine? 2 pi. So let's add, so this is one solution, but it doesn't meet our requirements. Let's say 2, 3, 4, 6 plus 2 pi. And let's get a number for that. So I'm going to come in here and I'm going to say 2.346 plus 2 pi. So I'm just going to add it to this. 2 pi. Well, that certainly fits, doesn't it? So that would be 8.629. And then I'm going to add 2 pi one more time. And now that's too big. Okay. So let's see where this falls on the graph. So if we look at the graph, and if I were to hit trace and I were to plug in 8.629, that works perfectly. But if I add 2 pi one more time, it goes too far. So what do you think I would have to add?
1 pi.
Let's try just adding 1 pi. So if I take this number, my so if I say 8.629 plus pi. We're guessing that it might intersect right here, right? Oh wow, that's too far. So how do I find that other one? Well, you could trace or you can find the intersection, but what you need to really understand is the how they're connected. Yeah, so I guess what I could do is I could just hit second trace, right? And come way down here. That's what you would do if you were taking a test, right? Like the AP Calc exam. So if I come in here and hit the second curve and then guess. So now it's 10. So how did I get that number? So the other value is 10.22. So these are the two answers right here, right? But what is that? Where does that come from? Well, that comes from the standard circle. We're looking for a reference angle of 2.346, right? Now that's not quite pi, but it's probably, where would that live? What is that in degrees? Let's see. If I go to mode, change this down to degrees, and then come back and hit arc cos of negative 0.7, it's 134 degrees. Now watch this. If I come around this way, this is why you have to know the circle, because the circle is going to help you make sure you have the right answer. I would come around 134 degrees. Okay? Now this is 134 degrees, but what is this reference angle? Because remember, that's the reference angle that makes the right angle triangle. So what is the reference angle? How do I find that? Well, I subtract 180 from the 134. And so this little reference angle right here is actually a 45-degree angle or close to it, right? So where is cosine negative? If cosine of theta is equal to the x over the r, where is x negative? In quadrants 2 and 3. So to get the next angle, what I would have to do is I would have to add 45 and 45. I'd have to add 90 degrees. Now what's 90 degrees in radians? 90 degrees in radians, what is that?
Pi.
It's pi over 2. So if I have 8.629, right? And I add, so let's try this. If I say if I have 8.629 and I add pi over 2, guess what I'll get? Okay. Now we're rounding some decimals and stuff, and that's why you have 10.22 versus 10.199. But that's where that comes from. Okay? So what did we learn about that? How could you do that quickly in a minute and a half?